Hi everyone. Previous classes we have completed successfully 2 units. Now we are entering to the sampling and sampling theorems on related topics. Third unit is sampling theorem. Now we are entering to the third unit, sampling and interpolation. Sampling and interpolation. In the meaning of sampling, what is sampling? Sampling means it is one of the type of conversion technique which converts the information from one form to another form. For example, when human beings produces sinusoidal signals, that is called voice signal. So by using sampling, by using sampling, by using sampling, a continuous sine signals, that means a analog information. A continuous sine signals, the time interval is equally split. A continuous time signals is converted using the form of discrete signals. Discrete means total sine wave is split into equal dot lines. Equal dot lines. That means the entire sine wave is to divide equal step sizes. That means the overall meaning of sampling is nothing but CT is converted into DT, continuous time signal. CT means continuous time signal and DT means discrete time signal. So simple form of sampling or sampler. Why we are using sampling and sampler? So by using sampling or sampler, we can easily convert the information using the form of CT to DT. It is a shortcut waveform or full waveform. A continuous sine signals will be converted using the form of discrete time signals is known as sampler or sampling. And we are observing first point. Often we want to be able to convert between continuous sine signal and to discrete sine signal representation of a signal. I am also explaining same. It is able to convert. It is able to convert continuous time, continuous time signals. That means CT. It is able to convert continuous time signals into discrete time signals. Continuous time signals into discrete time signals representation of a signal. So this is the basic operation of sampling in any electrical or electronic devices. It is need to use. Why? Because to convert the information from one form to another form. For example, we are taking an example of telecommunication systems. For example, we are taking telecommunication systems. In telecommunication systems, we are sharing information from one place to another place. We are sharing information from one place to another place. Uh, in this process, sender side and receiver side, uh, we are producing and receiving voice signal only. But the voice signal is will be the voice signal will be passing or propagates to the so many electronic devices, so many electronic devices. So why need to convert the signals is in the form of analog to digital? What is the main working purpose of what is the main object of how to convert the signals from one form to another form? So why we are convert the signals from one form to another form? Why? Because in the data communication process, in the data communication process, electronic devices are not understanding the language of continuous and signals. That's why it is requires to need to convert the signals from digital to analog to digital. So that means the sinusoidal wave is converted into digital wave. So then after electronic equipments easily understanding the digital code. Why? Because we are assigning some digital information 11100000111110 something. That means the binary code or digital code, it will indicate some message or it will represent some message, um, and it is easily understanding the machine languages. That's why we are need to convert the signals from one form to another form. So we are also using in this process we are also using several electronic techniques. We are using several electronic components. For example, generally in mobile telecommunication, we are using both microphone and earphones. Why we are using both sides, sender side and receiver side? Any mobile internally used both electric and sorry microphone and earphones. Why? Because they are like a converters. They are like a converters which converts the information from one form to another form. They are like a converters which converts the information from one form to another form. So by using microphone, it is a converter. It is receives the analog information and converted into digital. So the main working principle of microphone is it is converts the analog information into digital. And what is the main working principle of earphone? The main working principle of earphone, it is converts the information is in the form of digital to analog. It is converts the information is in the form of digital to analog. That's why we are clearly listening the audio information without distortion. So this process is continuously going on. Then after we can easily share the information without distortion from sender to receiver or receiver to sender. Both sides we are arranging different converters, so microphone and earphones. These two are works like as a by D and D by A converters. That's why we need to use sampling. That's why we need to use sampling. And in this sampling, okay, in this accomplishment through the process is known as sampling and interpolation. Okay, interpolation means data changing from one place to another place, and the sampling process, which is performed by an ideal continuous time to discrete time. Ideal continuous time to discrete time. That means C by D converter. Continuous to discrete. Continuous to discrete. Okay, that means not purely converted into digital. Only sampling sampler purpose is Our sampling purpose is it is con continuous sine signal will be splitted into equivalents, and then after by using quantizer, that is another topic. By using quantizer it will convert the discrete signals into digital signals. And the related diagram of continuous sine signal and discrete time signal, uh, when I am applying the x of t, it is a void signal. C by D continuous to discrete time signals. Y of n is a discrete. So a simple form of sampling. The interpolation process which is performed ideal discrete time to continuous discrete. Ideal to discrete. That means reverse operation of reverse operation of sampling. Reverse operation of sampling. Next one is periodic samples. Already I am telling how to already I am telling how to convert the sine wave into sampling discrete continuous signals. In sampling, C by D converter service. That means C by D means continuous. Y signal is converted into discrete. Discrete means two equal interval samples. So related waves are shown in the below. These are the related waves. These are the related waves. First one is original signal, and there is no splitted signals, or there is no dividing. So that means original signal is shape is like sine wave. By using sampling, it will splitted or divided to the equal intervals. Already we are observing second waveform. In second waveform, we are observing clearly sampled signal. Sampled signal. Sampled means discrete signal. That's why our topic is periodic samples. Periodic samples. Already in previous classes, we know sampling OEP is used sampling. Sampling is used for continuous time signals is converted into discrete signals. And although sampling can be performed in many different ways, the most commonly used scheme is periodic samples. Periodic samples. With the scheme, a sequence of a sample is obtained from a continuous time signal according to the relation y of n equal to x of n of t, where t is the positive real constant. As the matter of terminology, we refer to t as the sampling period. Sampling period. Sampling period means we are clearly observed. Sine wave is splitted or divided into two equal parts. Sine wave is and divided into two equal step sizes. There is no differences. Gap will be same. That's why these type of signals are known as periodic signals. Periodic signals means the time intervals are same. So that's why The gap is or the step size is known as time intervals, equal time intervals. So that is the main use of sampling. That is the main use of sampling. So by using sampling, we can easily split the signals from equal intervals with respect to the time and frequency. And next one is periodic sampling. Periodic sampling. The sampling process is not generally invertible. In the absence of any constraints, a continuous time signal cannot usually be uniquely determined from a sequence of its equally spaced samples. Its equally spaced samples. Consider an examples of continuous time signal x1 and x2. x1 of t equal to 0, x2 of t equal to sine 2 pi t. We if we have sample each of these signals with the sampling period t equal to 1, we obtain the respective sequence y1 of y1 of n equal to x1 of n of t equal to x1 of n equal to 0, and similarly y2 of n, x2 of n, n of t sin 2 pi n. So these are the two conditions with these represents two signals. And model of model of sampling. An impulse train is a signal of the form v of t equal to summation of k equal to minus infinity of k delta of t minus k of kt, where ak and t are the real constants, where ak and t are the real constants of weight impulse spaced apart by t. So, impulse train is a signal of the form. So the related diagram of continuous to discrete signal is shown in the below. It is represents model of sampling. Convert from impulse train to sequence. Convert from impulse train to sequence. The sampling of a continuous time signal X to produce a sequence Y consists of the following two steps. Here, first one is multiply the signal X to be sampled. Multiply the X to be sampled by periodic impulse train P. Yield the impulse train S. Convert the impulse train S to be sequence Y by performing sequence of weights of the successive impulse. These are the two conditions. Which is to convert the signals from one form to another form. Model of sampling variations. we are clearly observing. First one is input signal, CT, continuous and signal. First one is input signal. First one is input signal, that is in the form of sine, and the second one is impulse sampled, and second one is impulse sampled signal. Impulse sampled signal means the above wave is splitted into equal intervals xt, x of 0, x of t, or over 0, t, 2t, 3t, or 1, 2, 3, 4, 5, 6, 7, or a, b, c, d, e, f, whatever it taken. Just we are indicating the separation of the signals, and next step is output sequence. Next step is output sequence. That is discrete form. Why? Because pulses are splitted 1, 2, 3, and finally we are entering to the periodic signal. And finally we are entering to the periodic time impulse train. And finally we are entering to the periodic impulse train. So in periodic impulse train, there is no sine wave is appearing. There is no sine wave will be appearing. Why? Because sine wave is converted into different forms, and then after the step sizes are also adjusting equally. There is no up and low sizes. It is adjusting equal sizes. That's why it is called periodic impulse train. By using quantization, we can easily convert the signals from one form to another form easier and faster compared to the other previous technologies. And next one is model of sampling characterization. Model of sampling characterization. In this model of sampling characterization, just we are using several equations, time domain and frequency domain, time domain and domain, time domain and frequency domain. By using time domain, impulse response of sampling signal S is given by impulse response of sampling signal S is given by S of t equal to x of t p of t, where p of t equal to summation of k minus infinity to infinity delta of t minus kt. In the Fourier modem, modem, sorry, in the Fourier domain, the preceding equation becomes s double of omega ws by 2 pi summation of k equal to minus infinity to infinity x of omega minus ks.